the cosine curve. Y equals cosine of theta, or we could say y equals cosine of x. Much like the sine curve, the points for the cosine curve come from the unit circle. Remember, when we're taking a look at the terminal points, cosine really is the x value. It's the first value in each of these points. So if I wanted sine of pi over 2, I would get, cosine of pi over 2, it would be 0. So looking at all of these, I have this table down below. And these are really just all of those points kind of repeated again. So at angle 0, I get 1. At pi over 6, I get 3 pi over 2, and so on. So if I were to plot all of these points, it would form this curve. And again, our main important ones that are the easiest ones to graph are going to be our quadrant angles. So we're seeing these 5 points. We have 0, 1, pi over 2, 0, pi, negative 1, 3 pi over 2, 0, and 2 pi, 0. So it looks very similar to the sine curve. It almost just looks shifted over. So with the cosine curve, we're starting up at 1. In sine, we usually start at the origin. Again, it is periodic, so it continues this pattern over and over again. And the cycle starts to repeat itself after 2 pi. So every 2 pi, it's going to continue, which shows us that our period is from 0 to 2 pi. Notice our amplitude on this one is just 1. And we can see as long as we're starting up at the y-axis, we know that we haven't shifted to the left or to the right. All right, so the exact same thing applies, the same rule. So the amplitude is still that number we're multiplying cosine by. The period is still 2 pi divided by b. The horizontal shift is still from the inside, just backwards, remember, and the vertical shift is still d. Exactly the same rules as sine apply. So in our first one here, we're going to reflect, right? We see this negative. So when we see the negative out in front, that means we're going to flip or reflect over the x-axis. So all of the x values are going to stay exactly the same, but my y values are going to be the opposite. So the opposite of 1 is negative 1. Negative 0, well, is 0. Negative negative is positive 1, 0, and negative 1. And all of these points are just going to flip over that x-axis. So we'll see when it is negative, it's just flipped over. In the next one, we see we have an amplitude. So really that's stretching our problem. In this case, our amplitude is 2. So A is 2. Again, my x values are going nowhere, but what is happening is that my y value is doubling. It's multiplying by 2. So that's 2, 0, negative 2, 0, 2. We're going to start up at 2, still hit 0, down to negative 2, still hit 0, up. Oops. Helps if I can try to connect the dots. Something like that. With the 3, same concept, A is 3. So we're going to multiply all of those y values from the original cosine by 3. So we're going to get 3, 0, negative 3, 0, 3. Again, 3, 0, negative 3, 0, 3. Okay. For the next one, when we have fractions, it's very similar. Just remember, we're multiplying by a half, which is actually going to make it smaller. So my A is 1/2 here. Again, it's going to stay exactly the same for the x values. I'm just multiplying by a half. So that's a half, 0, negative a half, 0, a half. So it's going to be half as tall. Half, 0, negative a half, 0, a half. Okay, and we can do the same thing here. We have A is 1/3. Again, the x values are going nowhere. We haven't changed the horizontal here, but we are multiplying the original cosine by a third. So 1 times a third, 0 times a third, negative 1 times a third, 0 times a third, and 1 times a third. So it'll be just a little bit shorter or a little bit more squashed than the blue. Okay. And again, it continues on and on and on. The next we're going to look at is a horizontal shrink. So that's when the x value or the input is getting multiplied by something inside, technically inside parentheses. You just don't have to put them there. It's understood. So our x value is really what is going to change here. So I'm still going to have that 1, 0, negative 1, 0, 1, but things on the inside that affect the x before we take cosine will affect the x column. So what's going to happen really is my period changes here. My period, remember, is 2 pi over b. So in this case, b is equal to 2. So if b is going to be equal to 2, then let's plug that in. That's 2 pi over 2. So I get pi is my period. So I'm going to go from 0 to pi, and then I just have to cut in half a few times. Half of that is pi over 2. Halfway between 0 and pi over 2 is pi over 4, and halfway between pi over 2 and pi is 3 pi over 4. And then I just plot my points. 0, 1, pi over 4, 0, pi over 2, negative 1, 3 pi over, 4, 0, and pi 1. So if you notice, this is half as wide. And same concept here with the 3. So my b is equal to 3, which means 2 pi over b, 2 pi over 3, is going to be my period. So I'm going to go from 0 to 2 pi over 3. Half of 2 pi over 3 is going to be pi over 3. Half of that would be pi over 6. And then again, remember the trick, if I just add these two guys together, that's going to give me that last spot that I'm missing. So if I add them together, I am going to get pi over 2. And again, plot those points. So 0, 1, I have pi over 6. So we kind of need to cut these into, let's see, if that's pi, this is about thirds, so that's about half of those. So pi over 6 is about here-ish. Pi over 3, pi over 2, and 2 pi over 3. Certainly, if you were drawing your own graph, you could just count by whatever it is you need. So you could count by, say, pi over 6s here, instead of this graph that's counting by pi over 2s. All right, so for the next one, we see that our b instead is a half. Same rule applies, though, 2 pi over b. So really, when I keep change flip, that's going to give us 4 pi. Again, my y values are going nowhere, but what is happening is that I have 4 pi instead. So I'm going from 0 to 4 pi. Halfway would be 2 pi, halfway would be pi, and halfway again, or I could just add these guys together, would be 3 pi. Now, it's not going to fit on my graph, and that's fine. 0, 1, pi, 0, 2 pi, negative 1, and then I would start to dip back up again. So I'm running out of space, but it would continue on. Same concept here. So I have 2 pi over a third because b is equal to 1/3. When I keep change flip that third, I'm going to get 6 pi. So again, y is not being affected. Nothing's on the outside, but I do have from 0 to 6 pi. Halfway would be 3 pi. Halfway would be 3 pi over 2, and halfway between those would be 9 pi over 2. Again, definitely not going to fit on here. We'll just plot what we can. So we have 0, 1. We have 3 pi over 2, 0. And the next point would be somewhere down here. So it's definitely way more stretched out than the other two. Okay, shifting horizontally. So notice the number is being added to the inside here. So we're adding pi over 2. Remember, when we add on the inside stuff is backwards. So we're actually moving to the left pi over 2 spaces. Again, the y's are not being affected in any way, but the x's are getting changed. So we're really going to take this column and we're moving everything to the left pi over 2. So in reality, I'm subtracting pi over 2. So 0 minus pi over 2. Pi over 2 minus pi over 2, pi minus pi over 2, 3 pi over 2 minus pi over 2, and 2 pi minus pi over 2. Every one of these points has shifted to the left pi over 2 spaces. So this point here is moving left pi over 2. This point here is moving left. This one is moving. This one is moving. This one is moving. They're all moving to the left. All right, for the next one, everybody's moving to the right. So instead, we have pi over 4, so we're going to need some extra tick marks here. But every one of these, even if I just look at the graph instead of the table, every point is going to move to the right pi over 4 spaces. Oops, we need one more. So everything has just shifted to the right. So again, y stayed the same. And because it's to the right, I'm going to add. So I have pi over 4. 3 pi over 4, 5 pi over 4, 7 pi over 4, and 9 pi over 4. Okay. We can also move up and down. So when I'm adding a number on the outside, it's affecting the y column. So the x's are going to stay exactly the same. But what is happening is that my y's are all increasing by 2. So I'm just adding 2. That 1 plus 2, 0 plus 2, negative 1 plus 2, 0 plus 2, 1 plus 2. So everything has moved up 2 spaces. This point is up 2 higher. This one is up 2 higher. This is 2 higher. This is 2 higher. And this is 2 higher. We've just moved everything up, which is different than amplitude. We literally picked up the graph and moved it, whereas amplitude, we stretched it apart. We went higher for some points and lower for others. So when we're doing a vertical shift, we're just moving every point in the same direction, whereas when we are doing a when we are doing an amplitude change, we're stretching it, some up, some down. All right, in this case, we're going, so this was up, we're now going down 2 spaces. So everything is going down 2 spaces lower. Again, you could do this by just subtracting in the table. So that'll be, whoops, sorry, I didn't mean to keep the y's the same. The x's should be the same. So when we are just subtracting, that's going to give us, let's see, minus 2. So that's negative 1, negative 2, negative 3, negative 2, negative 1. Okay. And last but not least, we're going to take a look at some graphs and from there make a determination on what could the equation be. Technically, there's infinitely many solutions because all of these could have coterminal angles that would produce the same graph. Again, we want our midline. So this is the middle of my graph. So our midline is 0. I notice the amplitude is 2. I also notice that my period is different, right? I'm starting at 0, which means I haven't shifted left or right. Here's my 5 important points. I haven't shifted to the left or the right, but I have squished this thing. So this, I would say, is about 2/3, right? If we kind of estimate 1/3, 2/3, and that would be 3/3 to pi, I would say this is about 2/3. So 2 pi over 3. And we also notice that we actually do 1, 2, 3 of them in 2 pi. So 2 pi divided by 3. It's just another way to get your period. Okay, so if our period is 2 pi over 3, remember the formula for the period is 2 pi over b. So if our period is 2 pi over 3, that means b is 3. Okay. So we have A, we have B, our midline is 0, so we're not moving up or down. So that gives us that y is going to equal 2 times, this should say cosine here, cosine of bx, or sorry, instead of b we had 3, sorry, 3x. Okay. All right, for part B, we again have a midline of 0. It looks like our amplitude is a little smaller. Our amplitude is a half, and nothing else has changed. We have a period of 2 pi and no shifts. So that means that y equals 1/2 cosine of x. All right, in part C, we have, let's see, our midline again is 0. It looks like our amplitude this time is 4, and our period is 4 pi. So if our period is 4 pi, that means 4 pi is equal to 2 pi over b. And we could either cross multiply or do some kind of rearranging here. That would give us b is equal to 2 pi over 4 pi, which means b is 1/2. So that means y is equal to 4 cosine of 1/2 x. And last but not least, my midline here is at -2. So that means d is going to equal -2. I've got to go down -2, or down 2 spaces. My amplitude appears to just be 1, and it looks like my period is just pi over 2. So if 2 pi over b is equal to pi over 2, I can just kind of cross multiply here. I can get that 4 pi equals b pi and divide. So b equals 4, a is 1, d is 2. So y equals cosine